I'd like to introduce this next presentation on energy supply strategies for Spanish Antarctic Stations, Looking for Sustainability by Joaquim, Rabadà, Marine Technology Unit from the Spanish National Research Council.
The Spanish Antarctic Stations are located in the South Shetland Islands. Although they are only summer stations, they maintain a large number of scientific equipment recording during the winter. This assumes that a certain power supply is required during the 8 months that the station remains closed. During the summer, at Juan Carlos I station and after its renovation, the power supply is based on the use of 3 diesel generators of 130 kVA each, compared to the 2 40 kVA generators that the old station had, and also a storage of 72,000 liters of diesel is available. In addition, to take advantage of the energy produced, a cogeneration system was installed during the rebuild to use the smoke from the generators in the production of heat. The system is made up of 3 400-liter aluminum tanks connected to the exhaust of each generator where water is heated. Hot water is stored in a 2,400-liter tank at 80 Celsius degrees and pumped out to the different modules. As Juan Carlos I station is constructed in several modules, especially insulated pipes were used to reduce the heat losses in the transfer of hot water to the different modules. The hot water reached to the modules is used in 2 ways. The first, through water-air exchangers to heat the air that is used to maintain the temperature inside the buildings to a comfortable 18 degrees Celsius. And the second, to store sanitary hot water that can be used in bathrooms and kitchens. On the other hand, Gabriel de Castillo station has an experience carried out with a prototype of an autonomous generator that integrates the generator and the heat recovery unit for the production of hot water. This prototype has been in operation during 2 Antarctic seasons, demonstrating its usefulness by generating enough sanitary hot water for the use at the base and reducing the use of fuel to power electric boilers. But with the end of the summer campaign, the generation system change completed and the energy supply is only based in the use of renewable sources, wind and solar. At Juan Carlos I station, the system consists of 3,000 watts wind turbines and 24 solar panels field that produce about 6,100 watts. All this energy is stored in a bank of 24 batteries capable of holding about 100,000 watts per hour. This production and storage allow us to supply energy to devices during the winter with an autonomy of about 350 watts during 10 days, if at any time there was no wind. However, during the winter we have at least one period of absolutely no wind over the 10 days of autonomy, causing the collapse of the system. In the future, in a process that will start already in the 2021 campaign, our intention is to double the power generation capacity with 3 new wind turbines and at the same time double the storage capacity. The system will be completed with a small 12 kVA diesel generator. This generator will come into operation whenever the battery banks drop below a certain level of charge, preventing the system from falling due to the lack of wind. The entire system will be controlled and monitored from Spain via Iridium. In this way, the energy supply capacity during the winter could be 3 times from now and also with the security that there will not be cuts during the winter. In Gabriel de Castillo Station, a 3,000 watts wind generator has been used to supply power to scientific equipment during the winter. However, the approach to improving supply is different. A three-phase project will be implemented for the installation of an ethanol battery system. The first phase of the ongoing project has already done, consisting in the assembling of the entire facility in a 20-feet container for testing. The first results seem promising, and the system works with stability. The next two phases will be transporting and installing at the Gabriel de Castillo station within the next 2 Antarctic campaigns. Finally, we can summarize saying that during the southern summer, the cogeneration system significantly reduced the use of fuel, producing the necessary heat and sanitary hot water for the stations. The system has been running successfully in Juan Carlos I during the last 3 seasons, with daily fuel consumption around 500 liters per day. This amount is significantly below what was estimated during the remodeling project. The prototype testing in Gabriel de Castillo station also has showed the cogeneration capabilities with a small generator where it is possible to integrate both the generator and the heat recovery unit in a portable system. On the other hand, during the winter, the use of renewable energies is a hallmark of both stations, and the intention is to follow this line. However, the increase of the demand of energy for science equipment and the episodes of lack of wind during the winter suggest a backup in terms of maintaining the energy level of the batteries. Both options, Juan Carlos I station, wind and solar farm, and the Gabriel de Castillo ethanol batteries will require the installation of the small diesel generators. These generators had to be well and continuously remotely controlled from Spain in order to guarantee the level of battery throughout the winter. Thank you very much for your attention, and for further information please don't hesitate to contact the authors.